Welcome to Biocon Group's podcast series, where we get into processes that make our life-saving molecules. At the heart of biologics process development is the cell bank. This is where all the work starts. And this is the foundational element which is responsible for making our products that eventually make it to the market and meets patient needs. Today in this episode, we are joined by our guest, Mr. Chandrashekhar KN, who is a functional lead at Biocon Biologics R&D for the last 17 years. Thank you for joining us, Chandrashekhar, on this episode. And Chandrashekhar is going to help us understand the intricacies, complexities, and processes involved in creating these cell banks. Over to you, Chandrashekhar.
Yeah. Thanks for the invite, and I'm thrilled to be here.
So, can you break it down for us? What is a cell bank?
So, cell banks like a technical term, but ideally in a biologics manufacturing, cells are the starting material, and hence it's of highly it has its high value, and hence we need to preserve them. And cell bank is synonymous with preservation. So, a cell bank is a collection of homogeneous pool of cells and placed in an appropriate container. And each container contains pool of cells that is in a healthy state.
So all these containers which have the cells are identical to each other?
Correct. So the content itself are homogeneous, and they are placed in a ampoule or a vial that is specifically designed to be able to withstand and durable at lower temperatures.
So you mean to say the cells that are stored in a cell bank are essentially kept at ultra low temperatures?
Yes, again, depending on the type of cell bank, the cell which we preserve, there are different temperatures. Like if it is microbial cell systems, we need to go as ultra low temperatures. And for a mammalian cell, generally the cryogenic temperatures lower than minus 150 degrees Celsius are employed.
Yeah. So what are the type of cells that you typically work with in your development?
Okay. So it depends on the biosimilar medicine we are making and the complexity of the cellular machinery that needs to make this drug. Generally, we have been employing the microbial systems such as yeast, bacteria, and also we have mammalian systems such as hamster cell lines, murine cell lines, which are the mammalian types.
Yeah. So when you store these cells, how are these stored at? And you mentioned they are in ultra low temperatures. So is there a specific nature of the container that you look at when you are storing this? Because obviously glass like materials will break at that temperature. So is there a specific container that you preserve your cells in?
Yeah. So I wouldn't go into very much detail about the material of construction and all, but they have to withstand those lower temperature, and that's the easier part because many of the material are available. However, at cellular level, if you see, we need to use certain agents such as cryogenic protective agent, which are like dimethyl sulfoxide or glycerol, so which helps in protecting these cells. So it is the ampoule or the vial itself and the cell itself. So both contains a different mechanism while storing.
Right. So when you take your cells and you put them in these cryogenic preservatives, which help you keep the cells for a longer period of time. So what happens to the cells? Essentially, it will break down if you do not have this cryopreservative. When you add these glycerol and other components to it, it helps them protect. And how long does the protection last for? Essentially, what I'm trying to gauge is how long does a cell bank when created lasts?
Okay, so ideally they are immortal cell lines, like a transform cell, right? So we wish we were like that, and so there is no defined shelf life. However, from a scientific perspective, there are definitely the expiry, or you can store them for several decades for sure.
So when you store them, essentially I understand there are a lot of intricacies involved in creating one. So what are the steps that you follow in establishing and creating of a cell bank?
Okay. So essentially to prepare a cell bank, there need to be cells, right? And cells need to be in sufficient numbers so that we can put in multiple vials or several hundred ampoules. So what happens is cells are cultured under defined conditions and harvested when they are in a healthy phase. And then they will be mixed with the cryoprotective agent and they will be placed inside the containers, which we were saying, and then they'll be transferred to cryogenic or ultra low temperatures.
Right.
So during these procedures, we'll have to ensure there is the traceability, documentation. So these are other measures that are in place in addition to the scientific the requirements.
Right. So we hear these terms quite a lot, a master cell bank and a working cell bank. So can you, like MCB and a WCB, so can you shed some light on what are these?
So a MCB or master cell bank is the one where it's like a parent stock, which is the initial stock from which a working reserve is created, which is a working cell bank. So essentially what happens for a regular manufacturing batches, every time we go to the working reserve. So in this way, what happens whenever the WCB gets exhausted, you always have a MCB to go back, the parent stock, and prepare sublotting. So in this way, what happens, we preserve the cells continuously for the manufacturing batches across several years or the life cycle of the drug.
So how do you ensure the integrity, considering your entire batch or the product that comes out of these cells are so precious and expensive? So how do you ensure that the integrity of these banks are maintained?
Yeah, essentially, it's a long procedure. It is not few days or few weeks. So cell bank preparation will happen. After that, to ensure the integrity, so several characterization and tests will be performed, such as genetic stability, safety, right? Like they have to be free from adventitious viruses, microbes.
Right.
So identity, safety, and purity is given. And after that, genetic stability essentially ensures that they're stable till the cells are used in the manufacturing processes.
Right.
So in addition to this, there is a storage purpose, like where we'll have a controlled and defined condition. All this happens in a GMP environment. So there is a storage facility and with the criteria which will be looked after.
So you ensure that each of these working cell banks and master cell banks essentially remain uncontaminated, and the working cell banks are essentially there for a reason, that you do not end up impacting your main master cell bank in any ways, correct? Yeah. So what are the key hurdles do you experience in establishing one?
Okay. So essentially these are like living systems.
Yeah.
So interpreting them, knowing what happens to them is key. So in this, we face several challenges. So one of the thing is these have been used over several decades. So history of the cell lines become very important during cell bank preparation, but because that ensures what sufficient characterization we have to do, right? That will be taken back based on the history of the cell line. And after that, since we have to grow sufficient number of cells, so during that time, growth and viability is something which we'll have to monitor and then carefully see, and sometime there will be issues relating to that. And once prepared, the characterization is extensive. So most of the testing will also be outsourced to third parties, wherein there are proprietary methodologies employed. And that is where we will not have the access to everything because they are proprietary. So in this way, access to these information becomes important. Right. So this is one thing, and then they are stored for several years, as I said.
Is there a shelf life we're looking at?
So they are ideally immortal, so they can be stored. In that way, cell bank storage stability also has to be continuously monitored. And in addition to that, there could be something unforeseen, so we'll have to take care of the risk. And yeah, it is very similar to the financial system, the bank which we use. All the money you don't put in one place.
Oh,
so essentially you spread it across so that you make your risk lesser.
So cell bank sounds a lot like the bank we keep in money, precious and important. Thank you so much, Chandrashekhar, for being with us and shedding some light on some of these concepts around cell bank. And it has probably helped many of us understand the core concepts that are required in order to make and establish a cell bank.
Yeah, it's my pleasure. Thank you.